How's it going, Kin 516? I'm Hiroaki Takahashi, and today we're going to be talking about the lactate pathways. So we'll start off this presentation with the Cori cycle, and to kind of simplify what this does, and we're going to dive into it a little bit deeper in just a second, but to kind of simplify it, what this cycle does is takes the inactive muscle's lactate, take it back into the bloodstream, bring it all the way to the liver because it's one of the only few places where we can process lactate, and make it into glucose, which goes back into our bloodstream and back into the muscles that are being in use. So to kind of dive deeper into that, this process basically happens where the lactate makes its way into the liver, it mixes in with pyruvate, and pyruvate loses an amino group, gains a double bond oxygen, and allows it to kind of synthesize with the glucose to go ahead and turn this process into a working process to go back into the bloodstream and back into the muscle that we're using, and uses that for energy in whatever exercise that we're doing. This only happens at the 80% or higher. So if we're at almost RPE 8, or at RPE 8 and above in terms of work capacity, then we're going to be starting this process of lactate being transferred over to make glucose for the active muscles. And that is a Cori cycle in a sense. So blood lactate and the minute ventilation. So basically this line right here, or this graph right here, is going to describe this line, which is the blood lactate threshold and the obla or onset blood lactate accumulation. And what happens here is at a certain point for the lactate threshold, we're going to reach 1 nanomole and above, or 9% in blood volume. Basically, that is our current threshold for that. The more oxygen uptake that we have, the more blood lactate is going to increase. It's very simultaneous in what happens. So for obla, on the other hand, it takes a little bit more than that. It's 4 nanomoles versus the 1. And they used to be used interchangeably, but this actually a little bit different because one is a little bit lower than the other. So our lactate thresholds is at 1% or 1 nanomole versus 4 nanomoles for obla. And obla is what we're going to be using mostly. And increases in activity, the more lactate in our blood is going to be, and the more increase in activity that we do at that threshold, the more tolerance that we kind of build, so that we can kind of push that threshold a little bit further down than the original 4. So it's 4 and above, not necessarily at 4. So now we're going to move on to the discussion of lactate versus lactic acid, and Robergs and colleagues described it as something that we physically can't do. It doesn't exist in living beings and in our physiology. So it's a low pH level, which doesn't make it necessarily an acid, and the process for glycolysis consumes hydrogen in this process versus the lactate process, which doesn't necessarily. It actually takes in the hydrogen ions in tandem with the loss of hydrogen ions in glycolysis. The process of the energy releases ions, whereas lactate stays relatively the same. So it kind of just chills in the middle while glycolysis takes over, because that's the main energy source that we're going to be using in the active muscles. Okay, and finally we're going to be describing its uses and the consequences to sustain it. So, like I said before, the accumulation usually happens around 4 nanomoles and around 80% work capacity. So, the way it kind of gets affected with sustainability is the imbalance of glycolysis rate versus mitochondrial production. So if one or the other is lower, then we won't be able to necessarily produce we won't be able to transfer over enough lactate to go ahead and start the process. So if the glycolysis rate is a little bit slower, then we won't be able to kind of get the lactate that we need into our body and vice versa. Low oxygen levels and low flow in the skeletal muscle is also another reason why we won't be able to produce as much. If there's not enough oxygen, we won't be able to bring any of the blood and lactate into the liver. And the same thing, if our muscles can't flow better or flow enough, then the amount of work that needs to be done needs to be higher. And smoking can also be a big problem for that as well too. So if you are a smoker, then suggest stopping, so that the efficiency and the amount of breathing cost isn't increased, and the efficiency is decreased based on the fact that we're damaging ourselves. So it's something to think about when we're kind of in exercise, or if we're just trying to live a healthier lifestyle, is to kind of understand that these things can affect these energy systems to go ahead and make ourselves even more efficient or make us work even harder than we're supposed to. So be mindful, and hopefully this information kind of gathered very easily and very well for you in a very short amount of time. Thank you for watching, and we'll see you soon. Here are the sources.